Hello, this is exercise 12C, but again building more on our knowledge of vectors, and today we're looking at the difference between what are called position vectors and what are called displacement vectors. And there's a subtle difference between the two. You can kind of think of position vectors as almost like a coordinate, whereas the displacement vector is like a movement from one place to another, which may or may not start at the origin, but position vectors really are only ever start at the origin, so you can think of them as coordinates. So let's have a look at them. Position vector gives the position of a point relative to the origin O. So you can almost imagine two sets of axes passing through here. And we don't need to worry about the axes, but you know that's really what's going on. You've got this set of axes. At the center of the axes you've got the origin, and from the origin we're moving 3 to the left and 4 up. And so this vector here, A, is just like the coordinate. A is 3 across 4. So notice I've written it 3, 4 like this. But this is more of a displacement vector because it's indicating it goes from here to here. Whereas if you write it OA, that's a proper position vector. It's highlighting the fact that it goes from the origin to A. Now you might see it written in both ways. Very common to see it written in both ways, but you might write it as OA to indicate it starts at the origin. So OA is 3, 4, and there's my little triangle. A position vector is usually written with a single letter then, and there it is, and there's my alternative way of doing it. There again, that is very often underlined, but often in textbooks and in exams they don't write it. So I very often, if I'm writing a vector, will put A with a line underneath, but these days no one really minds if you do or if you don't. If you are underlined, fine, but exams and papers and textbooks don't, so they just put them in bold. They make them stand out in bold. So 3, 4, by the way, is called a common vector or a component form, but we've seen those before as well, so that's no great difference to what we're used to. Now displacement vectors then can start at the origin. So OA is a displacement vector and a position vector, so I'm writing it A. But definitely from A to B, this vector here is definitely not a position vector. This is from one point to another point where the original point is not the origin. So we call that a displacement vector. And there it is drawn properly. And AB, now you've seen this at GCSE, I'm sure. But AB, to get from A to B, you could go directly across, or you could go down here the wrong way, and then up here. Notice what I did. That down is effectively minus A because it's going the wrong way, plus that B. So I've written that as minus A plus B, but I don't ever really like starting things with a negative. So for that reason, we write it BA. B minus A, sorry. Interestingly there, notice that AB is B minus A. And so it kind of implies that PQ will be, well, Q minus P. Notice the order of these letters are the wrong way round. PQ is Q minus P. AB is B minus A. And that very often happens like that. So get used to that. I've written that again here. I've highlighted it here. If A is 3 minus 4, so I can write that as a position vector from the start of the origin. I could write it as OA, or I could just write it as A, and that is 3 minus 4. And again, OB, which I could write as B, and probably should, is minus 1, 2. And it wants me to find AB. Well, all I do is I use my formula which I've written up here. AB is B minus A. B then is minus 1, 2. But I've got to take away the A, which is 3 minus 4. So what does this give me? Minus 1 minus 3 is minus 4. And 2 minus a minus, well that's obviously a plus. 2 plus 4 is 6. So is that minus 4, 6. This isn't hard, is it? This is easy. Again, we've got P is 2, 5. And Q is 3 minus 6. Again, I can think of OP as being the letter P, which is 2, 5. You don't have to write all this out. I'm just really highlighting the fact you can do, if you like to. OQ is Q, which is 3 minus 6. And I've got to find PQ, so PQ is, remember, change the letters, Q minus P. And Q is 3 minus 6 minus the P, which is 2, 5. And if I do that, 3 minus 2 is 1, minus 6 minus 5 sounds like minus 11 to me. And that's it, that's PQ, written as a column vector. Find the distance PQ. Now look, the distance PQ is basically the magnitude of that vector. So to find the distance from here to here, an alternative way is to say what's the magnitude of the vector. So I do the square root of, you should remember the formula, you basically take that number, square it, take that number, technically it's minus 11, but in reality I'm ignoring the minus because it will disappear when I square it. And that's 121, 122, I reckon it's 122 square rooted. Should be 11.0ish, I assume, but I'm going to write it as root 122 because it's more accurate. And that's what I did last time as well. Good. Next question. If P is 3 minus 1, so again, just OP equals P, which is 3 minus 1. And OQ is Q, which is minus 2, 5. Find the coordinate of the point R such that PR is, alright, then it might be useful just to draw a little picture, it might help. So P is 3 across and 1 down, there's P. Q is 2 left but 5 up, about there somewhere. And it says to go from P to R, I go 3 left and 4 up. So I go 3 left, and I reckon it's around here somewhere. So I don't know exactly where it is. Let's put it there just because I don't really know where it is. But that's R. So PR is this minus 3, 4. And it wants me to find this point. Well, presumably, I can just do this. I can say, to get from the origin to P, I've got that vector, you see. I know that vector. That's P. And I want to find this vector, the position vector of R. The way I can do it is I can say that PR is R minus P. And if I can find R, then I know my position vector. So I can just put all those things in. What's PR? It's minus 3, 4. They tell me that in the question. Equals R minus P. What's P? It was 3 minus 1. And effectively I can move that onto the other side. It becomes a plus. So R is equal to, let's move it over. So minus 3, 4 is already there. Plus the 3 minus 1. Minus 3, 3 is 0. That's kind of what my picture was predicting. 4 minus 1 is 3. That's kind of, yeah, that's quite good, that. I like that. So it's not hard. But notice I fell back when I was not quite sure what to do. I fell back on my formula. PR is R minus P. I'll do the same here probably. MQ, find the point MQ. Well, let's just go back to my formula. MQ is Q minus M. And they tell me MQ is 1, 2. Do I know what Q is? Yes, I do. It's minus 2, 5. Minus M. Now I think this time I've got to move the M that way and move that 1, 2 back the other way. M is equal to minus 2, 5. I think that will move over and become a minus, a bit like this moved over and became a plus. So minus the 1, 2. So solving equations, isn't it? Minus 2 minus 1 is minus 3. 5 minus 2 is 3. I did that question without even thinking about drawing a picture because I fell back on my standard equation. I wanted MQ, so I wrote MQ as Q minus M and then filled the blanks. I wanted PR, so I wrote PR as R minus P and then filled in the blanks. So I'm hoping those questions are right. 0, 3. Yeah, that's interesting. Look, it says find the point. It doesn't say find the vector. So actually, I was right here to change it. 0, 3 does become 0, 3 as a coordinate. Minus 3, 3 is right. But technically I should write it as a coordinate because it says find the point M, not the vector. And that's it. That's pretty straightforward. I've said don't do 1b. I've no idea what's wrong with 1b. We'll have a look in class. but there's a quick 10-minute video on vectors, displacement vectors, and position vectors. Thank you.